Good day, everyone. We appreciate your presence in our webinar titled A New Way Not to Foul Up Your Measurement. I'd like to inform you that we will be recording this webinar today. The panelist session is planned to last between 20 and 25 minutes, after which we will open up the floor for a Q&A session. Kindly post your questions in the chat window and send them to the entire group. Additionally, when asking a question, if known, please specify the panelist you'd like to have address the answer. Thank you, and with that, we are pleased to introduce our presenters for this webinar. Speaking today will be Caleb Wyatt, I&E Manager of Goodnight Midstream, Steve Resnick, VP of Sales and Marketing with Angus Measurement Services, Clay Wernley, CEO and founder of Cotman Industries, and Elizabeth Cambry, Global BDM of the energy sector with Aculon.
Good afternoon. We're delighted to present Aculon Measurement Integrity Treatment, a groundbreaking solution designed to enhance the reliability of your meters and eradicate the need for ongoing maintenance expenses. This innovative surface modification treatment has a proven track record of preventing fouling buildup on both new and existing measurement devices. The AMI treatment is versatile and can be applied to a range of devices, including Coriolis meters, electromagnetic meters, ultrasonic meters, vortex meters, densitometers, and guided wave radars. In today's webinar, our primary focus will be on electromagnetic flow meters. However, we have an exciting upcoming webinar in December that will dive into the specifics of Coriolis meters. So stay tuned for that. Thank you for joining us today, and let's explore how AMI treatment can revolutionize your measurement integrity. At Aculon, we are experts in surface modification chemistry, and our mission spans many industries. Among these industries, the electronics market stands as a prominent arena where Aculon's technology finds its greatest demand. For example, by applying our specialized chemistry to laptop cases, we effectively can conceal fingerprints, ensuring a pristine appearance. Beyond electronics, our expertise extends to the realm of music, where we coat guitar strings to counteract the adverse effects of natural oils from our fingers, thereby preserving the acoustic qualities of the instrument. Moreover, Aculon's capabilities extend to waterproofing electronic devices like cell phones and tablets, shielding them from potential damage due to water exposure. In the oil and gas sector, we are working on innovative solutions for enhanced oil recovery additives, hydrophilic coatings to repel inorganic scales, coatings to repel drilling mud, coatings for pipelines and tubulars. We also treat downhole tools, sapphire gauges, oil storage vessels, and membranes that facilitate the separation of oil and water. What are the functionalities that we can give to a surface? We can modify surfaces to be hydrophobic or even super hydrophobic, causing them to repel water. Surfaces can be made to be oleophobic, repelling oil and preventing its adhesion. Aculon has the capability to develop surfaces that repel both oil and water, providing omniphobic properties. Alternatively, we can make surfaces hydrophilic, promoting water absorption or adhesion. We can also modify surfaces to be oleophilic, enhancing oil absorption or adhesion. Aculon offers solutions to reduce fingerprint smudging and enhance the cleanliness of surfaces. We also possess expertise in promoting adhesion between surfaces, enabling strong bonding in specific applications. The AMI treatment prevents organic deposits from sticking to metal surfaces by significantly reducing the surface energy of the substrate. This is achieved through the implementation of Cotman's Clean, Prep, and Treat procedure, which sets the stage for the application of the AMI treatment. For electromagnetic flow meters, the AMI treatment itself is two distinct nanoscale omniphobic treatments, AcuFlow for the probes and AcuFlow 5 for the liner. These make the surface repel both oil and water. AccuFlow forms a covalent bond with the metal substrate, ensuring a durable and long-lasting effect. These nanoscale treatments form a uniform monolayer with an ultra-thin thickness ranging from 2 to 4 nanometers. Notably, the AMI treatment possesses optical clarity, rendering it visually undetectable once it's applied to the surface. I will now hand it over to Clay Wernley, and he will discuss more on the topic of Kottman Industries and his clean prep and treat procedure.
Thank you. Over 7 years ago, Kottman embarked on a process to develop and collaborate with multiple major operators in the Eagle Ford Shale to perfect and develop the process needed to apply Aculon's patented technology. Kottman possesses a patent-pending proprietary procedure now towards applying nanotech to new and/or used assets in the oil and gas energy sector, and now owns several unique proprietary procedures for applying treatments to multiple assets and multiple substrates in the energy sector as well. The original objective was to apply Aculon's technology to a Coriolis meter mainly just to combat fouling issues. And in the process of doing this, Kottman successfully developed a comprehensive process involving special cleaning, special preparation, and special treatment. Since the origination of this procedure, Kottman has developed this procedure to mainly mitigate fouling issues in also mag meters, Coriolis meters, and multiple different types of measurement equipment. By utilizing this proprietary process for cleaning and preparation and applying the technology, it has enabled them to restore several fouled meters to pristine condition when applying Aculon's chemistry to the meter surface. New and/or used equipment can be brought to as good or better condition than a meter was when it was new. And over the course of this past 7 years, Kottman has treated over 6,000 units utilizing Aculon's technology. This long, dedicated research and development process and time in this project has demonstrated the effectiveness and reliability of the treatment in preventing fouling and ensuring optimal meter performance. Increasing reliability in the meter, decreasing the uncertainty of the meter was the focus of Kottman's overall objective over this project for the last 7 years. Furthermore, Kottman has also collaborated closely with leading meter manufacturers to validate Aculon's chemistry. Through rigorous testing, we established that the application of Aculon's chemistry had no effect on impact of the measurement ability and performance. In fact, it was found to enhance the reliability due to decreasing the fouling issues. AMI treatment. What is AMI treatment? AMI is Aculon Measurement Integrity. It's a combination of Aculon, nanoscale omniphobic surface modification chemistry, and Kottman Industries' proprietary processes and procedures for applying these chemistries to different substrates and meters. This combination has come together and collaboratively gave birth to Aculon Measurement Integrity, a cutting-edge solution that ensures measurement accuracy and reliability. After this collaboration, AMI had developed a strategic partner in Angus Measurement Services based out of Odessa, Texas. This strong partnership has really opened the door and gave a strong credibility to the industry itself. I'd like to take this opportunity to pass it on to Steve Resnick. Thank you, Steve.
Magnetic flow meters are one of the preferred flow technologies used for the measurement of produced water. Magnetic flow meters have many advantages that include no obstruction of flow path, no pressure drop, no moving parts, minimal straight run requirements, and diagnostics that allow for both process integrity and meter health. How magnetic flow meters operate: when energized, coils on the meter body produce a magnetic field. When a conductive fluid is passed through the magnetic field, a voltage is produced through the electrodes. A non-conductive liner, typically PTFE or ETFE for produced water, isolates the meter body from the conductive fluid, preventing a short circuit. The voltage generated from the electrodes are proportional to the flow rate of the process going through the meter. The higher the velocity of the fluid, the greater the voltage generated by the electrodes, the greater the flow rate. There's a picture off to the right-hand side of the slide that kind of depicts all of the components that I just discussed. One of the challenges of using magnetic flow meters in produced water is that they can become coated. You can see here on this picture that there is a hydrocarbon coating that coats not just the electrodes but the actual tube itself. If the electrodes become coated or insulated from the flowing fluid, the voltage measured by the electrodes is reduced and is no longer representative of the actual flow rate. This means that the meter is reading lower than the actual flow. Unfortunately, most produced water has some level of hydrocarbons present, and they tend to adhere to the liner and the electrodes, resulting in the under-registration of actual flow. The impact of this reduction in metering accuracy can have significant financial and operational implications, which we're going to be discussing later in this webinar. To address these issues, operators have established cleaning cycles. Several strategies have been employed to help reduce and optimize when meters are serviced. Some of the more common strategies to determine when a magnetic flow meter needs cleaning are proving, meter diagnostics, and even artificial intelligence. There are several different types of proving methodologies. There's in situ or inline proving, where a master meter is utilized to determine the performance of the meter. You can see on the slide here a typical master meter configuration. You can also remove the meter, inspect it, have it tested at the lab or even on site, and then reinstalled. Another type is in situ meter verification using a clamp-on ultrasonic meter. It is important to note that the magnetic flow meter under test is typically more accurate than the ultrasonic master meter. So this method is used to determine if there has been a change in the magnetic flow meter's baseline performance, or to determine if the magnetic flow meter's accuracy is outside of the accuracy of the master ultrasonic meter, which is typically about plus or minus 3%. Diagnostics are also utilized. Most magnetic flow meter manufacturers offer onboard diagnostics to help identify when coating is developing. These diagnostics can be monitored and sent via SCADA to develop a baseline and trend over time. I have an example of one manufacturer's use of conductivity to determine when a non-conductive fluid is present in the meter. If the conductivity drops significantly and stays at a low level, it's a very strong indicator that the meter has fouling and would need to be cleaned. Artificial intelligence, some operators have started to utilize AI to look at baseline and other variables to predict bad measurement actors, in other words, which meters need to be looked at, and use this information to prioritize and schedule their flow meter maintenance. Frequent magnetic flow meter cleaning cycles can be problematic and can have a negative effect on profits, operations, and safety. Some of the challenges include increasing H2S, requiring additional safety precautions, which can result in an increased potential for accidents. Increasing system or operational costs, as either a bypass line around the meter must be installed, or the meter must be shut in so it can be removed, cleaned, and reinstalled. Increasing demands on maintenance to schedule and perform the cleaning can be costly, especially as the cleaning frequency and the number of meters increase. Then there's the cost of the meter's removal and reinstallation. Each time this is done, the risk of damaging the magnetic flow meter increases. There are costs and scheduling challenges to have meters proved, and then depending on the actual cleaning cycle, a reduction in operational efficiencies, including line balance and custody transfer uncertainties, can occur between meter cleanings. So how do operators optimize magnetic flow meter cleaning cycles? Well, we're fortunate today to have Caleb Wyatt with Goodnight Midstream here to share his experiences in this area.
Good afternoon. I'd like to present the case study that took place with this treatment application and our company. The location for the study was in Eagleford, Kearns County, Texas. It took place between October of 2022 and July of 23. The problems we were facing were residual oil and organic buildup within the process facilities for produced water, as these have a tendency to adhere to magnetic flow meters, which in turn affects system line balance and leak detection. The infrastructure of this test was a closed-loop system consisting of 5 dual water transfer skids and 1 outlet meter. Each of these dual water transfer skids and system have been in service for just over 5 years. The water transfer skids consist of 2-inch mag meters, and the outlet meter is a 3-inch mag meter. We have a mixture of both Emerson and Anderson-Hauser meters. During this study, we decided to maintain a control group, the even number meters, 2 through 10, and treat the odd number meters, 1 through 11, including the outlet meter. And this gave us the opportunity to switch back and forth between the two systems and ensure that as water quality changed, we could verify and test how the treatment performed on water quality changes and oil influx due to new wells being brought on in the system. Issues created by mag meter fouling: a reduction in accuracy impacting line balancing and leak detection, as usually oil and organic buildups cause meters to read low, an increase in maintenance, both cost and time, a reduced lifespan of the meters, as meters are often rolled out, cleaned, and then placed back into service. This causes also a reduction on the meter life, as often most of the meters will be pulled out, and then while being placed back in, there will be damage to both the internal liner and the exposed liner on the end. There's issues related to over torquing, as most operators are not aware of the torquing requirements for a meter. If it's on a flange of 150 or 300 series, they do not often understand that the meter torquing is less. And then you also have just overall damage to electrical equipment related to the meter as it is rolled out and then put back into service. Or if it's hard piped, you have the headache of having someone come out and unwire it so the meter can be rolled out. You also see process disruption and increased downtime, increased potential for HSE issues such as H2S exposure, pinch points for fingers and hands, and heavy meters, handling heavy meters. You also see an increase in labor cost and workforce logistics. As you can see at the bottom, we have a balancing percentage for fouled meters. This is an example of when the meters were not treated and we were seeing balancing creep out between 10 and 20% over a 9 to 12 day time period. To ensure optimal line balancing within a tolerance of plus or minus 2%, meters were removed from the line and cleaned on a 7-day interval, as 9+ days started to see drastic increases in line balancing and affecting leak detection. Other tools used to determine dirty meters were also meter diagnostics or empty pipe, as fouling on the electrodes caused lower resistance and lower volume readings on each of the meters that were affected by coating or buildup. Challenges of cleaning meters on a 7-day interval included cost, both in-house labor and contract labor, safety concerns of H2S, pinch points, and lifting or rolling out heavy meters, decrease in reliability and continued quality of line balancing and leak detection, wear and tear on meters as they were continuously rolled out, cleaned and placed back into service, over torquing concerns, and electrical connection concerns, as often operators or pumpers would try to roll out a hard piped meter without having the proper personnel on site to unwire the meter so it could be rolled out and cleaned. We also saw uses of the incorrect gaskets being placed back into with meters with possibly exposed liners and doing damage to the exposed liner, or also deformation to the actual internal liner shape. And then this also created a logistical headache as you're trying to coordinate operators, pumpers, contractors to know proper torque specs, know when the schedule is to go and clean, and if you have a rotating hitch, that also creates another nightmare of you having new and old people going on and off hitch continually. When we were trying to maintain this balance on a 7-day interval, if you look at it, we would have been pulling and cleaning these meters 9 times between October 17th and December 12th. If you extrapolate that across 11 meters over a year, the likelihood of doing damage to these meters, as well as disrupting your producer or customer's flow and causing continual downtime and inaccuracy in your meter balancing and leak detection, causes a great headache that had to be corrected. As we searched for a solution to our continual meter cleaning, we came across Aculon Measurement Integrity in correlation with Kottmann. On December 12th of 22, we treated 6 meters with the AMI treatment. The odd numbered meters were our test group, and the even number meters were our control group. As we only had one outlet meter, we decided to go ahead and treat it to get the best results possible out of this closed loop system treating. Treatment was conducted in the field, and treatment took approximately 1.5 hours to go to the location, roll out the meter, clean it, treat it, allow it to dry, and roll it back into service. We felt by having a control group and a test group, we would be able to best monitor water quality changes on each of the receive points and see how the oil and organic material in that water would affect the treatment on each of the individual skids, and then as a whole affect the outlet meter and the system. During the entirety of this case study, we ran both our AI and line balancing systems in the background. As you can see on the graph depicted, we applied the AMI treatment on December 12th. And after it was applied to the 6 meters, we maintained a sub 1% balance for about 75 days. Then in the middle to beginning of February, we started to see a line balance creep. We continued to watch it and see if we could note or detect which meter was affected. We found that oil coating buildup had started on meter number 5 at DCF 22, impacting only one of the 6 meters on the closed loop system, not the outlet meter. This meter was then pulled, cleaned with a microfiber cloth, and rolled back into service. After the cleaning, the balancing stayed sub 1% for another 75 plus days. We then placed our control group meters back into service to see if water quality had changed or if something else in the system was affecting it. We then again saw, after 7 to 9 days, our balancing started to drift to 10+%. We then rolled out and cleaned our control group meters, placed them back into service, and again within 9 days they were creeping out of balance. We then placed the treated meters back into service and have continued to see good performance over the last few months. Here are just a few examples of untreated, treated, and treated meters that have been in service. On the left, you can see a meter that's fouled after just approximately 7 days. This meter has both organic and oil residue buildup inside of it, coating both the PTF liner and the electrodes. Here in the center, you can see that this is an example of a meter that has been pulled out, cleaned, and then treated with the AMI treatment. On the right, you can see a meter that has been in service for about 75 days. Notably, you can see beading on your PTFE liner, but most important, your electrodes are still clean and able to read accurately as flow flows through it. So at the end of the day, what really is the value of an AMI treatment on a produced water system? We've projected that over 6 months, we'll see a cost savings of about $80,000 on 103 meters treated. We anticipate to reduce maintenance from about 1,150 cleanings in 6 months to just 103 to pull out, clean, treat, and place back into service. We see a reduction in safety concerns by pulling 12 people off of the workforce of cleaning meters and being able to place them on other tasks where they have less exposure to H2S, pinch points, or heavy meters. We will see a drop in process downtime. We'll be able to go from approximately 1,724 hours of downtime due to cleaning and be only at 154 hours with the AMI treatment. 154 hours will consist of rolling out the meter, cleaning it, treating it, and placing it back into service. We'll also see a line balance increase by being able to keep it within a sub 2% tolerance window. We anticipate this will work for 6 months or probably even longer.
Thank you, Caleb. At present, we're providing treatment services, both new and used equipment, at our facility in Beeville, Texas. We have a quick turnaround on getting equipment in and out of Beeville and or on location if needed. We can reach out to multiple different areas in the South Texas region, West Texas region, Colorado region, North Dakota region by using some of our different trailers that we have established mainly for going out on location and performing these services. If we have to have any type of high horsepower cleaning, mainly in used Corioluses, they will need to be moved to our facility in Beeville. All others, mag meters specifically, can be new or used mags, we can be performed and executed these process procedures in the field effectively. Looking forward to moving forward with you. Thank you. Hello again, and thank you for your time. AMI has dedicated our efforts to ensure that this application and its products are applied and certified by a trained technician prior to reinstalling the equipment back in the line. By doing this, AMI can offer a very unique 10x lifecycle improvement or 6-month warranty against fouling. 10x lifecycle improvement example of, if you have to clean a unit once a week, that's a 1-week life cycle. We can warranty that product up to 10 weeks. This is also executed on a case-by-case basis. Consult with your AMI representative for further details on your applications and this limited warranty. Again, this is a very unique opportunity and a very unique product and service. We look forward to working with you in your field. Again, thank you very much.
We have one last slide that we'd like to share with you. We had a lot of questions early on when we were cleaning, prepping, and treating the flow meters, specific to Coriolis and magnetic flow meters. The graph that you see below is on a magnetic flow meter, since that's the focus for this particular webinar. But the question is, does the AMI nano treatment have an impact on the factory's original calibration? And the answer is no. What you're looking at here are two graphs. The upper graph is the original flow calibration from Endresen-Hauser's factory, which is NIST traceable in Greenwood, Indiana. This original calibration was done March 19th, 2019. In July of 2023, we took that meter and cleaned, prepped, and treated it at Endresen-Hauser's Pearland facility, which also has a NIST traceable flow lab. After the meter was cleaned, prepped, and treated, the meter was recalibrated, and as you can see on the lower graph, the calibration points did not move. So as demonstrated by the as found and as left calibration, there was no impact to the factory calibration of the AMI process.
And with that, we'd like to thank you for your time and attention. Please research our listed links for further details into the AMI treatment applications. We are looking forward to hearing about your unique treatment needs. Up next, we will be diving into the Q&A portion of our webinar for any questions you have for our presenters.